Hello. Hello. Hello.
हाँ सर सुना जाच्छे
सुना है
Huh. So welcome all of you.
गुड इवनिंग सर
So today I would like to discuss about the timer circuit, means the programmable timer, programmable interval timer or counter, which is 8253 or 54. Both are same. So I will discuss about the 8254. So is it visible?
No sir.
Hello?
Sir, this is visual. Only the PDF is showing.
Huh,
But the
huh.
content of PDF is not showing.
Okay. Okay. Right now? Is it visible?
only the PDF not the content
No, sir.
Only the PDF. Now?
yes sir
Yes, sir.
Okay. So for next 30 minutes, I will mute you all. Huh. So after 30 minutes, the doubt clearing session will be start. Until now, so I'll be delivered the lecture about this 8254 programmable interval timer or counter. Okay. So that's why I need to manage it. So right now I meet you all. Okay. So after 30 minutes, when I will deliver this lecture, I will discuss about the questions and the doubts regarding this topic. Okay. So listen carefully. So in 8085, all of you have used the software method, which is basically to use any register as a counter, like decrement it by 1 every time until it reaches certain condition. Okay. So normally we have used in our program, normally we have used the decrementing operation, that is the down counter. Okay, so suppose there is a register which is initialized by the instructions like mvi c comma certain value 05, and that c register will be decremented by 1 every time until it reaches 0 condition. Okay, so it is a software method, but in this method every time the microprocessor needs to calculate the time delay, and it engaged the full time about the delay calculation. Okay, so in software method, it is more time consuming. So the delay is achieved by decrementing a count value in a register using instructions in this way. So the disadvantage of this approach is the processor is locked in the delay loop and the precious processor time is wasted in just counting. So that's why we can use the hardware circuit method. There is a hardware method which is related to the 555 timer you have used in electronics lab. uh, but there are certain disadvantages, like in case of 555 timer, like in 555 timer circuit, there are several resistance and capacitance are related, and the values of this resistance and capacitance are fixed, so that so every time the delay which is produced by this 555 timer, it is fixed. Okay, now if you want to change the time interval of that delay, you need to change the values of the corresponding capacitance and resistances, so that it can be generated according to your requirement. Okay, the delay will be generated. So that's why some disadvantages are there in software method as well as in hardware method. That's why the Intel has discovered one such device, that is the combinations of the hardware as well as the software method. Okay, and that is the 8253 or 8254 IC, which is called the programmable interval timer or counter. So the next is so this can be used, so 8253 or 54 can be used for several purposes, like it is used in to generate the square wave, and it is used in event counter or real-time clock or digital one-shot or complex motor control purpose. So what is the feature of 8254 IC? Okay, normally 8253 and 8254, both ICs are same. Certain one difference is there, but the main is the difference between these two ICs depends on the frequency. Okay. So the difference is in 8254 the frequency is up to 8 megahertz, whereas in 8253 the frequency is up to 2.6 megahertz. Okay, it has the it has the capability to generate the accurate time delay. It has 3 independent 16-bit counter, or it can be used as a channel. So 16-bit counters are there, which can be used for down counting purpose. That's why 16-bit down counters are used. And there are several modes, like 6 different operating modes are available, which is mode 0, mode 1, mode 2, 3, 4 and 5. So different modes has different application or different configuration. It has both the timer operation as well as the counter operation, and it can be used to count in binary as well as in BCD format, or this can be used to interrupt the processor also. It is used by the 5-volt power supply, and that can be used from DC up to 8 megahertz. Okay. Here is the block diagram. Up to this much clear? Up to this much? Hello, everyone?
Sir.
Up to
Yes,
this
sir.
much clear?
Yes, sir.
Okay. So I will discuss about the block diagram and then the different modes. Okay. So this is the block diagram of 8254. So several blocks are there, like data bus buffer is here, through which the data buses are connected from D0 to D7. This is the read write control logic block, and here is your control word register. Now, and on the right hand side, there are 3 counters: counter 0, counter 1 and counter 2. Now these are all 16-bit counters. 16-bit count value can be loaded inside this counter, so that every time this counter counts from that position to the 0 position. All these are used as your down counter. Here two inputs are given as clock 0 and get 0, and one output signal which is called out 0. For every counter there are 3 signals. Among these 3, 2 signals are input signals, one is the output signals. Now this clock signal, for every counter it is given the clock frequency, so that based on this clock frequency and the get signal, which is used as your triggering signal, okay, until this one is been given, no counting operation will be started. So that's why these 2 signals are used as your input signals, and according to your inputs, given inputs, the output signals will be generated, the waveform will be generated, and using this output signal, different applications can be implemented using 8085 microprocessor or more than this. Now it is counter 0, it has 3 signals. Counter 1, it is another 3 signals like clock 1, get 1, out 1, and counter 2, that is clock 2, get 2, and out 2. All these are 16-bit counter. 16-bit counter. Okay, 16-bit value can be loaded like FFFF. Okay, so if FFFF is loaded inside this counter, it will be decremented by 1 every time until it reaches 0 condition. Okay. So in hexadecimal, so now this counter can be used to count both in binary form as well as in BCD format. Okay, in binary form, the maximum value that can be counted from 00000 to FFFF. Clear? But in case of BCD format, if it is if any value is given in BCD format, the maximum value can be from 00000 to 9999. That is in decimal format. That's why if it is in BCD format, the maximum possible number will be from 00000 to 9999. Okay, so you can use these counters as binary form or binary counter or BCD counter. Clear? So here data buses are connected through the microprocessor using data bus lines D0 to D7. Read write logic is there, through which the read and write operation can be performed, and this is the chip select signal. As in case of, you have seen the in IO mode IO, in IO mode IO or in IO interfacing, input output interfacing there, or memory interfacing, whatever, for every device, memory device or IO device, it needs to be enable first, then you can transform the data from or to that particular device. Okay, so that signal is called the chip select signal or chip enable signal. Now without enable this IC, you can't operate anything. So first one, the main thing is you have to load the address from where the read operation can be performed or can be written for write operation. Then the next address or the remaining address lines are used for address decoding purpose, so that the chip select signal, this chip select signal can be generated, and it enables this IC, so you can connect it for different operation purpose to operate the another function. Okay, these A0 and A1, these 2 address lines are directly connected with the address lines of 8085 microprocessor A0 and A1 line. Okay, now according to these 3 lines A0, A1 and CS bar, the combinations of these 3 signals is used to generate the to identify this counters, whether you can use the counter 0 or you can use the counter 1 or counter 2. The combinations of these 3 signals I will discuss after this slide. Now here is the main register, that is called the control word register. So all of you have seen in 8255 PPI, it has the control word register. Control word register. What is control word register? It is the internal register which is used to identify the different mode selection purpose, or it is used to identify the port selection, whether it is used as your input port or output port, and the sequential operation purpose. So without identifying the control word which will be stored inside this control word register, no operation can be done. So first you need to initialize the control word register using the control word. then you can transfer the data according to your requirement. So it is a very important register in every type of peripheral devices. Okay, so 8254 has its internal register called the control word register, through which the different operations can be initialized. Okay, so here is your internal bus, those are connected through these lines. So that is the block diagram. Next is the pin details. Already most of the pins I have described. Now here it's a for 24 pin IC, 24 pin IC, operates on 5-volt power supply. So here these are from 1 to 8, pin number 1 to 8, these are used as your data lines from D0 to D7. Clear? 19 and 20 number pins are used as in your used as address lines for A0 and A1. Now 21 number pin, it is used for chip select signal or chip enable signal. Read and write to control signals are here, as in pin number 22 and 23. 24 is connected to the 5-volt power supply. And here is your for every counter, like these three signals are 9, 10 and 11. These pins are used by the counter 0. This is the ground pin. This 14, 13, 14, 15, these are used by counter 1, and 16, 17, 18 pins are used by the counter 2. Is it okay? Okay, so next is the control word format. Okay, it's very, very important, so listen very carefully. Here it's a 8-bit control word format, just in case of any other peripheral devices. 8-bit format starting from D0 to D7. Now D0 bit, it is used to select whether the counting operation is performed in binary form or BCD form. Okay, that's why it is written as 0. If this bit is 0, so it is used as a binary counter, which is used as your 16-bit value that can be counted from certain values until it goes down to the 0 condition. Okay, and the next is if it is 1, if it is 1, it is used as BCD counter, or it's called the decade counter. Okay, the next 3 bits, which is D1, D2 and D3, these 3 bits are used to select the different modes. Like if these 3 bits combinations are 0, 0, 0, it is used as mode 0. If this is 0, 0, 1, then mode 1. If it is 0, 1, 0, this cross represents the don't care logic. But here in this case, or in most of the cases where this cross is defined, it is used as 0 for design purpose, easiest design purpose. So 0, 1, 0 mode 2, 0, 1, 1 it is mode 3, and 1, 0, 0 is mode 4, and 1, 0, 1 it is mode 5. Here, so these are used for mode selection. Now that is read write logic, that is D4 and D5, RW0 and RW1, it is given in this table. So if these are 0, 0, this is counter latch command. Counter latch command. That means if anything is to be, you need to read. You need to read what is the operation is going on using any counter. You can read the command, or you can latch the counter value. So if you want to check whether the counter has reached to certain condition, you need to check it. Okay, and that is the reading operation. You can perform it using this counter latch command, which is 0, 0. Now next bit is 0, 1, read write least significant byte only. So if you want to process any 8-bit of byte only because all these counters are 16-bit in size, 16-bit, but 8-bit can be read, or 8-bit can be write according to your requirement in this way for least significant byte, 8-bit. And for if it is 1, 0, it is used as your upper or most significant 8-bit only. You can read or write both. And if all this total 16-bit number can be loaded in this way, first 1, 1, it means the you need to first load the least significant byte first, 8-bit, then you can load the upper 8-bit, so that full 16-bit full 16-bit count value can be loaded, and it can be loaded in such way according to your control word generation. Okay. Then D6 and D7, these 2 bits are used to select the counter, and 0, 0 defined if you want to connect any system with counter, operate any system using counter 0, then you have to select these 2 bits as 0 0. If you want to select counter 1, then this bit should be 0 1, then 1 0, and 1 1 actually read back command, or it has no such operation. It is called the illegal operation. You can't operate anything else. Okay, so only the read back command will be there, nothing else. So okay, so is this clear? Is this clear up to this much? Control what? All of you? Hello?
Yes, sir.
Yes, sir.
Hello, hello.
Hello?
So counter latch comment, can you explain once more?
A counter latch means you can check the register counter value if any counting operation is going on. Okay, that is the counter latch. So it can be used to latch that value so that you can check whether it is reached to certain condition or not. Okay, just check the counting value when it is going on. Okay. So I will discuss later after delivering this lecture. So write down any doubts or confusion or queries. Okay, then we will discuss. Okay, until this much clear. Okay, so next I will go to the modes, different modes. Okay, different modes. Okay, so here are 6 modes written in shortly, in short format. There are mode 0, mode 0, mode 1, mode 2, 3, 4, and 5. Mode 0 is called interrupt on terminal count. Interrupt on terminal count. Mode 1 is called programmable one shot, or it's called the retriggerable one shot. Mode 2, it is called the rate generator mode, or it's called the divide by n counter mode, or frequency divider mode. Mode 3 is called the square wave generator mode. Mode 4 is called software triggered strobe mode, and mode 5 is called hardware triggered strobe mode. Okay, so for every mode, get pin has some function. Either it has the control operation, either it is in high format, high value, or if it goes low, what will happen, that will be discussed in every mode. Okay, and the reloading value, count value, can be performed in any mode or not, that we'll discuss in later. So this is the waveform in mode 0. So how very clearly, you must listen carefully how it works, how this waveform can be generated, and what is the use of this individual waveform for every mode. Like mode 0 has this type of waveform, mode 1 has different type of waveform. So you need to clear the concept why it is there and how it is formed and what is the application of these things. So here is your clock frequency given. Now if you want to write a value, suppose if you want to count a value 4, okay, load a count value 4. So from 4 it goes to 0, 4 3, then 2, then 1 0. So it is started, but it will be started if get signal is high. So when get signal is high and the counter value is loaded inside the counter, then it starts the counting from this position, from the falling edge of one pulse to the rising edge of the next pulse is called 1 T state. Okay, so 1 clock period. So your counting operation will be started from this position. Suppose in this position up to this clock signal, it is written 4, counter value is loaded. Now the counter will be start from the next position, from this position 4, then 3, then 2, then 1, and then 0, and the output signal will be high. So initially when counting operation is going on, your output will be low, and after reaches this final terminal count or the final value, it goes high. So it is used this pulse, it is used to operate anything else, so that it informs the microprocessor using the interrupt signal. Okay, so after generating this type of signal, or this type of delay, it informs the processor, so that the processor will be perform the next operation according to this delay. Okay, so that's why it is called interrupt on terminal count. When terminal count is reached, one interrupt will be generated and it informs the processor, so your delay operation is completed. Okay, now, so this counter counts only if the get signal is high. But suppose at any time if get signal is low, what happened? Counter is started already. Okay, counting your operation. Now when this get signal low, until it goes high again, counter will not be activated. Okay, so when the get signal high again, from low to high transition, again again the counting operation will be started from the resume position, and it counts the value up to 0. Like in this case, my right value is, counter value is 5, so it starts the counting from 5, then 4. At suddenly my get signal is low, so it stops the counting, and until it goes high again, no counting operation will be started. And when it is high, then it is started from after this position, like until this one 5 and 4 has been performed, then it will be started from 3 2 1 0. Okay, and your output will be high after that. Clear? So that is the operation of mode 0, which is called the interrupt on terminal count. Next is the mode 1, which is called programmable one shot, or programmable retriggerable one shot mode. Now in this case, here is your clock frequency. Now one count value is to be loaded inside the counter, which is 4, assume. After writing the value inside the counter, until you use the get signal, which is acts as a triggering signal in this case. If get signal high, then after using that get signal, the counting will be started. So here in this position, I have loaded the value as 4. Okay, but at that time get signal is not activated, so my counting will not be started. And when this get signal is high, that means it is activated, my counter will be started from this position, means falling of this pulse. Okay, so from this position it will be started as 4, then 3, then 2, then 1 and 0, and output will be high. So initially output will be high, but when counting is started from 4 position, from the initial position, the output goes low, and until it reaches the terminal count, the output will be low, and it will be high again if counter has been reached final or terminal count. Okay, so here in this case also, if at the time of counting, if triggering signal is low again, or in any way it goes low or deactivated, at that time what happened? The counting will be stopped, and it will be stopped until this position, until this triggering signal or get signal will high again. Okay, so if get signal high again, it will be started from the initial position, not from the resume position. Okay, so until this get signal is high, or if trigger is there, so that means if trigger is there, then the counting will be started one by one. At the time when trigger is low, that means no counting operation will be there, and until you have again triggered the signal, the counting will be started from the initial position. That means from 4, then 3, then 2, then 1, then 0. Clear? So that's why it is called triggerable or re-triggered again until it is high. So that's why it is called the programmable one shot or programmable re-triggerable mode. Clear? Then next mode is called the rate generator mode, or it's called the frequency by divide by frequency mode, or it's called the frequency divider circuit. It is used in that way. So how this waveform can be generated? Again, here the clock signal is given. You have to load a count value as 4 inside the counter. The get signal is high initially, assume. The output will be high initially from the count position. Okay, so if 4 has been loaded in this position, the next pulse is from this position, because this is not here present, because this position is under this operation. So until this position, that until you get the next pulse, the counter will not be started. So that's the counter will be started from this position. The falling edge of this pulse to the rising edge of the next pulse is for one counting purpose, one clock pulse. So 4, then 3, then 2, then 1, and output goes low for the last cycle only, 0. Okay, so 4 to 3, 3 to 2, 2 to 1, then 1 to 0 will be low only, then again it will be high and it will be counted in this way. Okay, so that's why it is for one time, or the last cycle will be low only, any other cycle will be high for the entire operation. Okay, so that's why it is called the rate generator mode, or it's called the divided by frequency mode. Okay. Then the next is the very important mode, which is called the square wave generator mode. In this mode actually what happened, if my count value, so here is your clock frequency which is given here. So what will be the output if my count value is loaded in even number, like 4, my count value is 4, then how many signals, or how the square waveform can be generated? According to the formula, it is given as, if n is even, means the number of count value is even, then the signal will be high for n by 2 counts. That is, if it is 4, then 4 by 2, that is for 2 clock cycle it will be high, and 4 by 2, that is again 2 clock cycle, it goes low, again 2 clock cycle it goes high, then again 2 clock cycle it goes low. In this way you can get the square wave square waveform. And if the count value is loaded in odd number, like 5 or 7, whatever, so assume 5. So if the count value is 5, then the waveform will be high for 5 plus 1 divided by 2, that is 6 by 2, 3 clock cycles. It will be high for 3 clock cycle, and it goes low for 2 clock cycle, like 5 minus 1 divided by 2. Okay, according to this value, this formula. So it will be high for n plus 1 by 2 and low for n minus 1 by 2 if n is odd. Okay, so in this way this waveform will be generated, and this can be used to operate the other system which is connected to the microprocessor 8085. Okay. Next mode is called software triggered strobe. Software triggered strobe. So here is your clock frequency. Now one count value is to be loaded inside the counter, which is here in this case we have assumed that n equals to 4. So count value will be 4, and initially so assume the gate is high, no problem. As soon as it is loaded inside the counter, or it is initialized by the instruction, it is loaded inside the counter value, the count value, the counting will be started. Counting will be started from 4, 3, 2, 1, and the last cycle will be 0. In this case, if get signal or the triggering signal is low again, then it will be started from the initial position, and it will be started from 4, 3, 2, 1, 0 in this way. So every time if get signal is high, then whatever you have to load it inside the counter, that value can be decremented by 1 every time until it reaches 0 condition. Okay, as soon as it loads inside the counter. If get signal is low, what happened? If get signal is low, it will stop the counts, and the counting operation is stopped. So it will be started again if the get signal or the triggering signal will be high again, and it will be started from the initial position from 4, 3, 2, 1, then 0. The last cycle will be low. So that is used by the software method, software triggering method. Like as soon as it gets loaded inside the counter, the counting will be started. But in case of hardware, that is the mode 5, which is called the hardware triggered strobe. In this case, every time, whether you can load inside the count value, load the count value inside any counter, until you trigger the signal, okay, no counting operation will be started. So you need to operate the get signal, which is very important in this case. That's why it is called hardware triggered stop. You need to trigger it by hardware method. So you have to apply the get signal, a triggering signal, to start the count. So if count is loaded, then until you trigger the signal, no counting operation will be started. And if get signal is high, that means you have triggered the signal. It will be started from 4, then 3, then 2, then 1, then 0, and the last cycle will be low. In this way, or in this implementation, if this get signal goes low again, then what happened again? The counting will be stopped, and you have to apply the get signal or by triggering signal manually or by a hardware method. Then the counting operation will be started, and it will be started from the 4, from the initial position, from 4, 3, 2, 1, 0, and it goes low. Okay, so this is the difference between the last two methods, means software triggered strobe and hardware triggered strobe. Software triggered strobe, as soon as it loads the value inside any counter, the counting will be started. And in case of hardware triggered strobe, until you press the triggering signal or get signal, no counting operation will be started, whether it is loaded inside the counter or not. Okay. So these are the different modes. And now this is the interfacing circuit by which you can connect any 8085 with the 8254 to operate any delay, or the it is used for any timer operation or counter operation. Now here the address, lower 8-bit address is connected like AD0 to AD7. Lower 8-bit address is connected via this latch, so that A0 and A1 can be used as your address bits, and the D0 to D7, these are used as your data bus. Okay. Now other address lines, which is A8 to A15, along with this IO/M bar, it goes into a decoder circuit so that chip select signal can be generated, and it enables this IC. After enable this IC, what you need to operate, you can perform that operation, and you can perform the read operation or write operation using these two control signals, read and write. Okay, so read bar signal, it is used to read the count value, and write is used to write the count value or any control register for writing format. Okay, the control word can be written in this way. So this is 8253 or 54. Okay, so that's all about the 8254 peripheral IC. Now clear up to this much? Clear?
Sir, please can you explain the mode 2 rate generator?
Mode 2 rate generator. This one.
Yes, sir.
Okay, so here is your clock frequency. Now this is if you want to operate a counter, suppose I have used the counter 0, so I have loaded this value 04 inside that counter. Now my get signal is high, and it will started the counting from this position. So the next pulse is from this position. So falling edge from this pulse to the rising edge, this pulse. This is the starting point after loading this value inside any counter. So it will be started from this position 4, 3, 2, 1, and the last cycle will be 0. Okay, so that is the rate generator. And if
Sir, after this,
yes,
the third cycle, it is written 0,03210.
no, yes, if count is loaded again as n equal to 3. Now since I am assuming 4, that's why it is started from 4, 3, 2, 1, then 0. And if count value is loaded as 3, so it will be started from 3, 2, 1, then 0. Suppose you have loaded another value as 5, so it will be started from 5, 4, 3, 2, 1,
4,
then
3,
0.
2, 1.
Okay,
Achha.
so every time you need to load the new value after performing the current operation.
One second.
Anything else? Anyone? Do you have any queries?
Sir, what is the function of ALE? This peripheral.
ALE.
Yes, sir.
Where is ALE? Here in this
Interfacing.
case. Here in this case.
Yes, sir. Yes, sir. Yes, sir.
Address latch enable, because these are multiplex address and data bus 80 to 87. Now at a time either address can be transferred or data can be transferred. Now in which condition the address will be transferred and when the data will be transferred, it based on this signal implementation or the principle, working principle of this signal. Address latch enable, if latch is enabled at that time address will be transferred. So if ALE signal is high, then latch is enabled, and if latch is enabled, the output from this latch will be address only, no data will be processed. And if latch is disabled, that means data will be processed according to or in this way. Okay. So ALE, the function
Okay.
is address latch enable. When latch is enabled, only address will be transferred. When latch is disabled, just opposite to this one, what will be transferred? Data. Okay. Next.
Sir, please open mode 2 page once.
Huh?
I have a question. Sir, please open mode 2 page, mode 2.
Mode 2. Okay. Yes. Okay.
So first, in first output line, so
Huh.
first it counts 4, 3, 2, 1.
Because the
So again, again it is written. So again it is written 3, 2, 1. Then again 3, 2, 1, 0. So why this type of?
I have discussed this one right now already.
Yes,
First,
sir, yes,
the
sir,
count
sir.
value.
You said
First count value is
you said that.
first count value is 4. Okay. So if the count value is 4, the counting will be started from 4, 3, 2, 1, then 0. Okay. But after completing this operation, I have changes this value as 3 from 4 to 3. My count value is now 3. So the counting operation will be started from 3, 2, 1, 0.
3, 2, 1. 0.
Okay. So that's why here 3, 2, 1, 0 is represented. Okay. After
And
that,
sir, next 2, 1, 0.
So if the count value is 2 in this way, so actually here it is not given. Suppose from first one is 4, then 3, then you have changed your count value as 2, then 1 in this way. So suppose the next count value I need to upload it as 5. So what will be the operation? So it will be started from 5, 4, then 3, then 2, then 1, then 0. So after completing each counting operation, you can reload it. Okay, reload the count value. Okay, the next.
Sir, we have to use all the 3 counter at a time, or we can use one by one.
One by one.
C1, C2 down counter.
One by one, because according to the control word, okay, which is here. This control word, it is used to select only one mode at a time and one counter at a time, because you have to load the counter value, some value. Okay, how can you load the value at suppose if you want to operate any one of these 3 counters? Okay, so you have to load this value inside this control word according to this position. Okay, so if you want to use 2 counters at a time, how can you load these 2 values at the same time inside one register? It is not possible. So every time which counter you need to use, you have to define it here. That is the function of control word, every control word. Because without this control word, microprocessor can't recognize, or even though 8254 cannot be used, or cannot recognize which counter you have chosen or which mode you have selected. According to that, the required number of operation can be implemented.
Okay.
The next. Anyone else? Why the participants are so less? Participants are there, 29. Huh? I've given the link.
Sir, can you say about key debouncing?
Huh? Which one?
Key debouncing, sir, last day topic.
Key debouncing. Okay, key
Yes, sir.
debouncing, actually there are several number of keys, several types of keys are there. Several keys are there. Like touch button is there, like mechanical push button is there. So when you press when you press any button, it can be closed or it can be open. So it is called the normally closed button, it is called the normally open. Okay, so sometimes contact will be closed. Sometimes the mechanical contact, if it is mechanical switch, okay, the contact will be less. Okay, so when you give some signal, when you press the button, that means the contacts are added or it is with contact. Okay, but as soon as it release, it is contactless. So that means when you press the button, the signals are affected from this position, but there is no signal will be stable as soon as it is given. So it takes certain amount of time for stable condition. Okay, otherwise the signals are fluctuated. Okay, so it needs certain amount of time, which is called debouncing, and this fluctuation is called the debounce, or sorry, bounce. It is called the bouncing problem. Okay, now debouncing is to minimize the bouncing. You have to take that input as a stable condition. Otherwise, there are, if any signal is fluctuated in this way, how can you consider that fluctuation? Because there are some errors are already, the noise has been implemented. You can take that noise as your input. So you have to ignore that noise after certain amount of time when the signal is stable condition. Okay, so you have to ignore that bouncing position or bouncing time in with respect to microprocessor, not to consider this bouncing position or with noise signal as your input. Okay, your input should be in such way it is in stable condition, so your input either 1 or 0, not in between any fluctuation. Clear? That's why debouncing technique has been used. Now there are several software ways are there. There are different hardware method is implemented to avoid that bouncing problem. Okay, now what is the use of software method? Now if you can perform a delay of such time when any signal is bouncing. Okay, if you ignore that time, or if you generate the delay of that time, you can ignore actually the noise with noise signals, and after when the signal is stable, you can consider the input as your input from this position, not the previous one. So you have to delay that position, so that after that delay you can consider the next thing as your input, actual input. Okay, so that is called the key debouncing technique.
So what is handshake signal?
Anything else?
Handshake signal, handshake.
Huh?
Handshake signal, handshake signal.
Handshake signals. No, handshake signals means if anyone handshakes with anything, anyone. So that means certain time of signals has been exchanged. Okay, how do you do, or how are you? Okay, so these type of signals for any human being. Now machine can be used to exchange these signals. Why you need this signal exchanging? Because CPU has much more speed compared to the other devices. Okay, so within the specified time, if any slow responding device is not ready to transfer any data byte, either data can be lost, or data can be read again and again. The same data can be read. So to minimize these two situations, either data cannot be lost, or the one single data cannot be read again by the any device or any microprocessor. Okay, now to minimize these type of situations, some signals are exchanged before the actual data transfer. Like if any AD converter circuit is to be used with microprocessor, okay, now some signals are exchanged before the analog to digital conversion. So the signal, those are exchanged with the microprocessor and the ADC. The signals are called handshake signals. So some signals are exchanged prior to data transfer or before the actual data transfer. It's called handshake signals. Clear? Okay, next. Okay, one thing I need to tell you, everyone, that quiz 2, the due date was quiz 2, it is given. Okay, now some participants has given the quiz and he or she got the marks, but after due date, some students has been answered this question. Okay. Why it is happened? Because I have given such due date. No quiz will be assigned or no quiz will be marked or evaluated after due date or due time. Okay? So don't do this again. Those who have performed this type of things, don't do this. Okay. So I have given certain amount of date and time, so that within the specified time you have to complete your quiz and submit it. Okay? Don't submit the quiz after due date and due time.
স্যার বলছি কুইজ ওয়ানটা না দিলে অসুবিধা না তো কিছু?
Huh? Sorry?
কুইজ ওয়ানটা মানে ওয়ানটা তো দেয়া হয়নি সেটা।
Quiz? I can't hear you. Sorry, I can't hear you.
কুইজ ওয়ানটা না দিলে কিছু মানে প্রবলেম নেই তো, মানে ওটা তো দেয়া হয়নি।
না না, কুইজ 1টা তো আমি ক্যান্সেল করে দিয়েছিলাম তো, ওটা যে that will not be evaluated due to some error. Okay, but quiz 2 was very important. So those who have submitted the quiz 2, no problem, but those who are absent or missing by somehow, he or she was not able to submit that quiz 2 within the due time, they have submitted the quiz after 1 day or 2 day. Why? If you have any problem, you can call me, you can discuss with me or inform me, or you can mail me. Okay, without documentation or official information, I can't help you. Okay, I will not consider any type of quiz assignments or anything else. So don't do this. If you have any problems, so first inform me. Without information, no one will be entertained. Clear? So those who are absent now in this class, so inform them that not to do this type of things. The quiz must be given for certain purpose. Okay, that can be evaluated in such way so everybody gets the right marks according to your CA evaluation. So don't do this. Okay, you must submit that quiz or assignment or test within the specified time limit.
বলছি এই পিডিএফটা তোমাদের পাঠাননি ক্লাসরুমে?
কোনটা? এটা
এই পিডিএফটা?
এই পিডিএফটা পাঠাইনি, বিকজ আগে আমি এটা বলে নিয়ে তারপরে পাঠাবো। যেগুলো আমি পাঠিয়েছিলাম,
আচ্ছা,
যেগুলো যেহেতু আমি ক্লাস ফার্স্টে অনলাইন তার জন্য, বাট নাও ইট ইজ রেডি, উই ক্যান মেট according to my schedule, like according to routine. According to routine, I have class on Wednesday and Friday. Okay, so this online class will be fixed according to this way: every Wednesday, every Thursday, every Friday. Okay,
same time.
Same time I will inform you. Okay, I will inform. Every time I will inform you. Okay, I will schedule the meeting and the link will be given into the Google Classroom or whatever in your Google group. Yeah, I think if you have any problem, I will upload this video also on YouTube. Try to implement this. You can check it from the YouTube also. Okay. So any queries? Anything else?
Sir, conversion pulse is same as triggered pulse.
Sorry?
Or anything other?
Sorry, I can't hear you.
Conversion pulse. Conversion pulse is similar to trigger pulse.
Where is the conversion pulse?
Sir, in conversion delay, ADC interfacing. Interfacing, sir. Conversion delay.
Conversion delay. No, it is the separate thing.
Yes, sir. It is not trigger delay, sir, or anything else similar to trigger?
No. Trigger is not there. So do you have any queries? Any other queries?
স্যার বলছি ওই রাজশ্রী ঘোষকে তো আনমিউট করবেন, নো তো মিউট হয়ে আছে বলছি আমাকে আর কি।
আমি তো সবাইকেই আনমিউট করলাম।
ও বলছে ও মিউট হয়ে আছে, ওই জন্য বলতে বলেছিলাম আপনাকে।
হয়েছে তো ও কি নিজেকে মিউট করেছে?
না, ও যে আনমিউট করতে যাচ্ছি বলছি হোস্ট হ্যাজ মিউটেড মি এরকম বলতে দেখাচ্ছে।
All participants are unmuted. অনেকে পরে জয়েন করেছে হয়তো, অনেকে পরে জয়েন করেছে। যারা প্রথম থেকে ছিল তাদেরকে সবাই ইয়েস হ্যাঁ টেল মি।
Can you explain me one thing in the zero can you go once?
Sorry, I can't hear you properly. Some background noise is there.
Hello.
Can you use the chat? You can. Hello. 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 Can you ask me again? What are you asking me? Can you ask me the right last participant? Hello. Do you have any queries? Any question? Hello. Do you have any queries or question? Soham Munshi, raise hand. What is? Do you have any queries?
সোম মুন্সি মিউট হয়ে আছে।
অ্যাকচুয়ালি যারা পরে ঢুকছে তারা মিউট হয়ে আছে। এট এ টাইম তো ঢুকলে সবাই আনমিউট হয়, তাও আমি আনমিউট করলাম কারণ পরে ঢুকলে তো দেখাবে। অনেকে বেরিয়ে গেছিল ক্লাসে প্রেজেন্ট হতে, আবার বেরিয়ে গেছিল। তো যদি ক্লাস না কন্টিনিউ করো সেভাবে থেকে লাভ নেই, কিন্তু যারা প্রেজেন্ট থাকছো প্রথম থেকে লাস্ট অবধি থাকো, যারা থাকছো না তাদের মাঝখান থেকে ঢোকার কিছু নেই। So I think you don't have any queries. So can I end the meeting now? Hello everyone. Can I end the meeting right now?
Yes, sir.
Yes, sir.
Okay. Thank you all. Thank you.
Thank you.
Thank you, sir.